Okay, welcome to the Crow Show. I got a cool clip about the sun, UFOs, light in general, and a project update. Okay, so the Crow Discovery Project on day 8 has reached just under 8% of the goal for funds. I want to thank you all who have contributed and shared and followed. Truly appreciated. In this clip, I'm going to talk a little bit about full spectrum shooting and why it's so important, and that is one of the things I'm seeking to upgrade. That's a lot of power to have that ability. Anyhow, here we go into the clip. On my last clip, we were talking about the path of the sun, and what you're looking at here is a globe in Geneva somewhere. I think it's in a museum. The squiggly kind of figure 8 thing is called an analemma, and what you're looking at there is the Tropic of Capricorn and the winter solstice. There's the equator on the globe and the equinox. You'll notice that right above that is where the analemma pinches together, and then up on the Tropic of Cancer is the summer solstice. Now, like I said last time, these old maps and globes tell you so much. The shape there, the figure 8, is called an analemma, and I'm going to show you what that's derived from, how we get that shape, and why it's important here. So if you shoot the sun over a year at the same time of day, you get this shape in the sky, and you can see the arrows showing you which way the sun is traveling. In the upper left is the summer solstice. Now that's when the sun is at its most powerful and the hottest, yet the sun is the most distant from us. That is because the angle of the sunlight is hitting us at 90 degrees. On the far right is the winter solstice, or when the sun is weakest. The sun is actually closest to Earth at this time, and the reason the sunlight is cooler is because it's hitting us more obliquely. Now, the center point there is where the figure 8 comes together, and the solstice would be a little bit right of that, actually dead center probably between those two things. I didn't map it exactly. Now I'm going to give you a live demonstration of the ruling class knowing this and using this and tracking this. So here we are at the Vatican at St. Peter's Square, and you're looking at an obelisk that was taken from Egypt in a city called Heliopolis that was worshipping the sun, and you're looking due east. On the left is a summer solstice sun, middle is equinox, and then on the right is a winter solstice. Now I'm going to break this down for you. They're actually tracking this and have been for centuries. If you look straight down on the obelisk, you can see all those little lines. Those are solely for tracking the sun. That's why they're there. That's what their purpose is. These people understand the importance of the path of the sun, and they understand the influences. And this is true of scientific astrology as well. Now here's the angles. 32.5 degrees takes you off to the left there to the summer solstice, and dead center is due east, which would take you to the equinox, and then on the right would be the sunrise of the winter solstice. Now what I'm going to do is line this up so that you can kind of visualize. There's the analemma, and this doesn't line up perfectly, but you can see what it represents here. On the left is the summer solstice, on the right is the winter solstice. Now to put that in perspective, if you were looking at the horizon from the Vatican, this is kind of what it would be. This is not to scale, but that's the kind of visual image that represents what's being tracked here. So for many centuries, and actually millennia, when they brought this obelisk from Egypt to Rome, this was what it was about. They took it from a city that was worshiping the sun, and they have tracked the sun ever since. Now, this is all about the path of the sun. The importance cannot be understated for human beings. And again, old maps, old globes, if you want to learn about this, those are great places to start. But now we're going to talk a little bit about UFOs and light in general and full spectrum filming. Okay, so here's a little graph that shows you the very narrow spectrum of light that the human eyeball sees. That little tiny kind of pink band in there is what we can see with our eyes. Now, upgrading camera equipment will take us into the ultraviolet, which is up, and down into the infrared, which is, you know, quite a bit more than we can see. And here's another view of it. The little squiggly line on the bottom shows you the frequency of the waves. You know, as you get up into ultraviolet, they become shorter wavelengths, and as you go out into infrared they become longer. Now I'm going to demonstrate some clips that I've shot that if I had the ability to shoot in invisible spectrum. And now there's two stills taken in this. There's one still, that's why it jumps, and there's another still, and I use those in a second to zoom in. But you can see the magnetic halo on this object. You got to wonder, if it was shot in full spectrum, you know, what would we learn? Would we be able to see heat signature, energy signature? Here's the still, and I'm going to zoom in and do a little graphic here. And this is typical of a lot of the UFOs that I'm able to zoom on. You see a black core that's not see-through, a fuzzy edge, and then kind of a magnetic halo on the outer ring. Here he comes again, just to give you a view. And if he had been too close to be in focus, he would have been see-through. This object is in space. I know a lot of people are going to doubt that, but I can assure you with my experience, this object is in fact in space, and it would have been a great one to have shot in full spectrum. So here is the third filming of the lunar wave event. This one is very clear and quick compared to the 2012 shooting, and another great example. I just wonder, if you could shoot these in full spectrum, what would you learn? I mean, what would we be able to see? And there's actually more about full spectrum in the waves that I guess I don't want to talk about openly and tip my hand. So here comes the wave from the top, right here. There's the first wave, and there's the second one, and you can see how much faster and how much clearer it is than the 2012 footing. Now, chemtrails. This is my telescope on a chem plane. You know, you really need a telephoto lens to do this. It's just so hard. There was a UFO. Now, shooting this in full spectrum, I think, is really going to pay dividends. Here's the orbish looking object. I had him in frame for about a second because I was trying to keep the scope on the chem plane and get a good look, which is very difficult to do. And I don't think enough work has been done filming the chem planes, particularly in IR UV. Now there's another chem plane high. I know a lot of folks again are going to say that's not a chem plane. I can assure you that's a chem plane. This is a low humidity day, and there's all these little orbs buzzing around. But the thing about them is they blink in and they blink out. Now if we could shoot in IR and UV, would we be able to see where they're coming from? Are they still there, or are they literally popping in from somewhere? You can see when you zoom on these that they also have kind of a light halo. It's darker, but it looks almost like a heat radiation halo to me. There were 7 or 8, and they literally, this one that's in frame now, I think he blinks out. I haven't watched this footage in a while. Let's keep an eye on him. Yep, there he goes. He blinks out. Now you can still see a dark spot, but then he continues to go away. Anyhow, I can't understate the importance of being able to shoot particularly UFOs, chemtrail objects, and the lunar waves with telephoto equipment and full spectrum equipment. And again, if you'd like to support the Crow Discovery Project, there's links in this video. I thank all the folks who have supported me, and there it is. Cheers.